Hi, in this video I am going to discuss Edexcel IAL Mathematics Mechanics M2 May 2023 paper. All the questions will be discussed in this video. First question based on vectors. Impulse. A particle P of mass 0.3 kilograms moving with velocity 5 meter per second. The particle receives an impulse capital I Newton second. Immediately after receiving the impulse, the velocity of the particle 7I plus 7j. So initial velocity is given. The initial velocity before receiving the impulse is 5I. Final velocity is given after receiving impulse is 7I plus 7j. And the impulse also given, that is, impulse is just left as I. The vector impulse is nothing given. Find the magnitude of impulse. Okay, we'll find the, first we'll find the vector of the impulse. So A part, we know the equation I equal mv minus mu. Magnitude of impulse means first we need to find the vector of the impulse, impulse vector, like a velocity vector. So mass is given as 0.3 kilogram. So that will be 0.3 into 7I plus 7j minus 0.3 into u is 5I. Yeah, solve it. When you solve, you will get 0.6I. So here you will get 2.1I, here 1.5I. So finally 0.6I plus 2.1j. This is the impulse vector. The question is about magnitude. So you know that if there's a vector A is say R equal AI plus bj, the magnitude of R is equal to square root of A squared plus B squared. The direction is tan inverse B over A. So we'll use that idea. So magnitude of impulse vector is equal to square root of 0.6 squared plus 2.1 squared. That will be equal to 2.18 or 2.2 Newton second. Okay, B part, the second part or B part, find the angle between the direction of I impulse and the direction of P immediately before collision. Immediately before collision, it's along I, that means horizontal. The direction of the velocity before collision is horizontal. So if I find the direction of impulse, that is with horizontal, we already normally find it. If there's a vector R is equal to AI plus bj, the angle of the or direction of the vector R is given by tan inverse B over A, that is with I direction. So same way we found the impulse vector 0.6I plus 2.1 j. So tan theta with horizontal or with positive I direction, tan theta is equal to 2.1 over 0.6. So theta with horizontal or with I direction according to this definition. So the tan theta is equal to tan inverse 2.1 over 0.6. That will be 74.1 degree. The initial velocity u is already along I direction. Therefore, the angle between I and u is equal to the same answer, 74.1 degree. Okay, second question. A particle P is moving on a smooth horizontal plane at time t, which is greater than 0. The position vector of P relative to a fixed point O is R vector. It's given by R meters, and the velocity of P is V meter per second. The velocity vector is given, that is velocity vector is given as 40 squared minus 5t I plus minus 10t minus 12j. That is the velocity vector. When t equals 0, the position vector is given 2i plus 6j. Find the position vector when t equal 2. Okay, so A part is given when t equals 0, the position vector is given, that is 2i plus 6j. Okay, we need to find the position vector at time t equal 2 seconds. Nothing. You know that when you differentiate position vector r, you will get velocity vector. So the opposite way, when you integrate the velocity vector, you will get the position vector. We'll integrate it. To find the constant, we are going to use this one, because when t equals 0, we'll find the constant. Then we'll get the general equation. Then in the general equation, we'll substitute t equal 2. You will get the position vector when time t equal to. Normal procedure. It's a normal usual thing. Okay, so we know that when you differentiate position vector, you will get velocity vector. So integral of dr will be integral of v dt. So integral of v is given 40 squared minus 5t I plus minus 10t minus 12j dt integral. So we'll integrate separately I and j easy. So integral of 40 squared minus 5t I dt plus integral of minus 10t minus 12 j dt. Okay, when we integrate the constant, we have to assign I and j separately, because I and j are independent vectors. They are perpendicular among them. They are not depending on each other. So we have to put the constants for vector I and vector j separately. Okay, we'll integrate it. So that's going to be the vector r. So that's the vector r left side. So that is going to be 4t cube over 3. So 4 by 3 t cube minus 5 by 2 t squared. 5t squared by 2. So 5 by 2 t squared plus c1 I. Plus this one minus 10 squared by 2 means minus 5 t squared minus 12t minus 12t plus c2. There should be a constant c2 j. Okay, so this is the position vector r. So when t equals 0, it's given. So when t equals 0, we'll substitute t equals 0. When t equals 0, it will become 0, 0, c1i, 0, 0 plus c2j equal to 2i plus 6j. So from this, c1 is equal to 2, we have I should be equal to I, c2 is equal to 6. Okay, so the general equation for position vector r is equal to 4 by 3 t cube minus 5 by 2 t squared plus 2i plus minus 5t squared. You can take the minus out. Okay, such matter. Minus 5t squared minus 12t plus 6 j. Okay, so at time t equal 2 is the question. So at time t equal 2, substitute t equal 2, you will get the position vector r. So when t equal 2, r is going to be, substitute 2 is going to be 8. 8 means 32 by 4 by 3 into 2 to the power 3, that is 32. So that is 4 by 3 times 2 cube minus 5 by 2 times 2 square plus 2i plus minus 5, 2 square minus 12 into 2 plus 6 j. Solve it. You will get the precision vector at time t equal to, you will get 4t squared minus 5t, when you solve that you will get 8 by 3 I minus 38 j. Check it. Okay, B part, when time t equal capital T, particle P is moving in the direction of vector I minus 2j. Moving in the direction of vector means that's the directional vector of the velocity. Because particle moving in the direction, so particle will have motion always along the direction of velocity. So particle is moving in the direction of the vector I minus 2j. I minus 2j means that's a directional vector of the velocity. But we know how to find the direction. Tan inverse, if the vector is given by, generally I am saying ai plus bj, the direction is given by, with the x-axis, with the unit vector I, the direction is given by tan inverse b over a, or tan theta equal b over a. But for the velocity vector is given generally. So the velocity vector, the direction of the velocity vector by using the given velocity vector, we can say tan theta is equal to, generally, the component of the j component, that is minus, we don't need to consider the minus sign here when we are taking it, it's just we'll think about the magnitude, that is or minus, yes, minus 10t plus 12 over 4t squared minus 5t, that's the angle, minus, I took it out, minus 10t plus 12 over 4t squared minus 5. So here this is the j component, tan inverse or tan theta equal j component over I component. So that means minus 10t plus 12 over 4t squared minus 5t. But it's given the direction, it's moving in the direction, means that's the directional vector of the velocity is given by this one. That is minus 2 over 1. Minus 2 over 1. That is when t equal t. So I'll substitute that here. So this is the general direction. So when t equal t, minus 10t plus 12, this is a general equation, simple t, over 4t squared minus 5t is this one. They are saying the directional vector is this one, means minus 2 over 1. Okay, now solve it. When you solve this, you have to find the capital T. That's the question, is you find the value of t, B part. Okay, solve it. When you solve, you will get cross multiply, minus 10t, minus will get cancelled. So 10t plus 12 equal 8 t squared minus 5t. So it will become 2t squared. If you want, I'll write 8t squared minus 20t minus 12 equals 0. Divide the whole equation by 4. 2t squared minus 5t minus 3 equals 0. Factorize it. We will factorize it into t minus 3 into t plus 2t plus 1. So from that, t is equal to 3 and minus half. But time can't be negative. So the correct answer, t equal 3 seconds. So the final answer, t equal 3 seconds is the correct answer. So finally we can say the time capital T, they have to find the value of t. Therefore t is equal to, finally, t is equal to 3 seconds. That's the final answer. Okay, C part. Find the exact magnitude of the acceleration of p when t equal 2.5. 2.5, they are not giving unit, 2.5 seconds. So we have to find the acceleration when t equal 2.5. So that we can find like this. You know, when you differentiate velocity, you will get the acceleration. So dv over dt is the acceleration. So acceleration is going to be differentiated. 4t squared means 8t minus 5i minus 10j. That is the acceleration vector. So the question is, find the magnitude of exact value of the magnitude of the acceleration at 2.5 seconds. Okay, so if you want, you can find the acceleration vector at t equal 2.5 seconds. So when t equal 2.5 seconds, the acceleration vector will be equal to substitute 2.5 into 8. That is 8 into 2.5 minus 5i minus 10j. So that's going to be 20 minus 5, 59 minus 10j at t equal 2.5 seconds. So magnitude of acceleration at that time they are asking at 2.5 seconds. So 15 squared plus 10 squared, square root of. So that you will solve, you will get 5 root 13 meter per second squared at t equal 2.5 seconds. Okay, question number 3, this diagram is given, and also it said that AP to PC, this is parallel line to BC, AP to PC, AP PC is equal to AQ to QB 2 is to 3, and also AC equal to AB, that also given in this question. And what they are doing, they are folding it. So it's the triangle is folded by using PQ, and this shape is obtained. We have to find the center of mass of this one from PQ. Okay, we can do like this. The height is 9y. So if the height is 9y, and if I take this height is h, this height of the triangle APQ, this height is h if I take it. So h over 9y, that also 2 over 3. So h will be equal to 6y. So this height is 3y, 6y means this is 9y. So this will be 9y minus 6y. This is going to be 3y. Okay, so for the triangle ABC, its center of mass will be at 1/3 from the base on the median, right? So it's a symmetry. The median will be exactly at the midpoint that connects to the vertex A. So the center of mass of ABC will be at a distance of 1/3 of 9y. That means it will be 3y from BC. So it will on the line PQ. Center of mass of ABC will be on the line PQ at the midpoint, because AC equal AB. So the median drawn from BC to A will be the intersect points of BC, the center point. Therefore, the center of mass of ABC from BC will be 3y. That will be at PQ. So the center of mass of ABC will be at PQ. Center of mass of ABC from BC equal to 1/3 of 9y equal to 3y. So it will be at PQ. Okay, so we can find like this. I explained clearly when I discussed October 2022 M2 paper, first question I explained that. That means if you have system of particles like there is a particle M1 at a distance x1, there is a particle M2 at a distance x2, and there is particle M3 at a distance x3 and M4 at a distance x4. The center of mass of this system of particles, the x coordinate would be given as x bar is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 over total mass m1 plus m2 plus m3 plus m4. Now if we remove a particle, say for example particle M3 is removed from this system, what will be the new center of mass if they ask? I derived it during October 2022 question number 1. So there we can show that this is total mass M1, M2, M3, M4 total mass means how can I show the new center of mass when M3 is removed from the system? That could be shown like this. So from the initial center of mass, that if I add M1, M2, M3, M4 as capital M, so capital M x bar is the center of mass of system of particles. 4 particles are there, M1, M2, M3, M4. From there, if I remove the third particle M3, so I can do this minus M3 x3 equal to the total mass now. M3 is removed, so M1 plus M2 plus M4, that I'll call M1 into x1 bar. M1 into x1 bar. x1 bar is the new center of mass. We can just derive simply. I'll derive it during the October 2022 question 1. So we can use this way: initial total mass when there are 4 particles or whatever the number of particles, its center of mass, minus this is the portion removed. Particle M3 is removed from the initial system. Its coordinate center of mass is x3. So m x bar minus m3 x3 is equal to, this is the total mass of the remaining particle into x1 bar is the new center of mass after the particle M3 is removed. Also remember that if there is a particle on the other side, either side, say for example you are trying to find the center of mass from the y-axis, but there is a particle, something is on the left side, that should be written with minus sign. If there is a particle on the left side at a distance x5, then the total mass when you are writing this one, it should be minus, or that is you should write m5 into minus x5. Say for example, I'll tell that also. If there's a particle, now that part you understood, removing part. If there's a particle on the left side, that is M5 mean, now system of the center of mass of these system of particles written by M1x1 plus M2x2 plus M3x3 plus M4x4. We'll take M3 also there now. Now if this fifth particle on either side, because on the other side of the axis about which we are trying to find the center of mass, that will be written as m5 minus x5. So we have to consider direction also. Direction means if on either side, one side should be taken positive, other one should be taken negative. Okay, so when I use these ideas, the removing idea also, removing method, so we can find, there are 2 methods we can do. We can find one method, find the center of mass of this trapezium and continue. We can find the center of mass of the trapezium from the PQ, then we proceed. Nothing wrong, you'll get the same answer. The other method, one line you can write it by considering removing of this portion, then it is added. When you are added also, say for example, if that also true. Now there is a particle, again I am drawing, it's okay, M1 at a distance x1. There is a particle M2 at a distance x2. I'll put some particle here also, M3 at distance x3. Okay, the center of mass of these 3 particles from the y-axis, x bar is equal to M1 x1 plus M2 x2 plus M3 minus x3 over total mass M1 plus M2 plus M3. We can show M1 plus M2 plus M3 as capital M, the total mass. Okay, now we are adding another particle, that is 4th particle at a distance the right, M4 to the right at a distance x4. What could be the new part, new center of mass? Adding. Earlier I explained removing. Now we are adding it, so that we can write mx bar. This is the initial center of mass when there are three particles, m1, m2 and m3. This is the total mass. So mx bar plus, we are added fourth particle, m4 at a distance x4 is equal to M1. M1 is, what is it? M1 plus M2 plus M3 plus M4 after adding that one into X1 bar. X1 bar is a new center of mass after we add the particle M4. Okay, so we can approach these methods in this question like this way. We can assume from the triangle ABC, the center of mass of the triangle is on PQ. So we found it on the line PQ at the center due to the symmetry. From the triangle, this portion, the upper triangle, which is bended, folded downwards, we assume it is removed. It is removed. So what could be the center of mass? We can write an equation. Then it is added, the line, the triangle which is removed is again added or attached like this. What could be the center of mass of the new section? Okay, so we'll find that. So for that we need to find the masses of the triangle, masses of this triangle, everything we have to find it. Okay, so the mass of the big triangle, we'll find it first. Okay, we'll find the mass of the triangle, mass of ABC is equal to, we can name it M, that we can make it capital M because that's a total mass, is it? Even after you fold it, that's going to be the total mass. That is half into base 6x into height 9y, mass per unit area, density, rho. So it's going to be 27 xy by 2 rho. Sorry, 20 by 2, yes, 27. 27 xy rho, that's the mass of the ABC. Then mass of the triangle, the smaller triangle, mass of this is the triangle we are going to imagine it's removed then added upside down. Is it added upside down? So mass of APQ is equal to, we can name it M1, that is half into this PQ. How much? This is 6x. This PQ is, you know the ratio, same ratio, that's AP to PQ, sorry, AP to AC is 2 by 3, means in this triangle PQ to BC is also 2 by 3. So 2 by 3 means it's going to be 4x. It's going to be 4x, is it? So these triangles are similar triangles, so that is going to half into the base PQ. If you want, I can say PQ, the length PQ is going to be 2 by 3 of 6x, that is 4x. The line, the length PQ. So half into length PQ is 4x into the height h, we found it, simulate 6y. 6y rho. So that's going to be 12 xy rho. Okay, its center of mass is upward direction. From PQ, it's at a distance 1/3 of 3y. Sorry, 1/3 of 6y, because this h is 6y, 1/3 of 6y, but upward direction. But after it's folded, the center of masses are going to be downward. So we have to take one direction positive, I told. So we'll take downward direction positive, means this is going to be negative. So center of mass of APQ, the triangle APQ, is equal to 1/3 from the base, 1/3 of symbol h. Symbol h is 6y, so that is 2y. Center of mass from PQ is at a distance 2y. Center of mass of ABC is 1/3 of 9y, that is 3y, that is on the line PQ. So we'll take anything above on the other side of PQ. Upward direction is negative, downward direction positive we'll take, because if the particles on either side of axis about which we are calculating the center of mass is, one side should be taken negative, other one opposite side should be taken positive. Okay, so this is 12xy. So now look at here. So the center of mass of the triangle ABC we are going to measure all the distances from PQ. Center of mass of the triangle ABC is on PQ, that is distance of the center of mass of ABC from PQ is 0. So I told that how to write the equation when something is added and subtracted. Mass is added or mass is subtracted. So now mass is subtracted from ABC we are going to take. So initial center of mass of the triangle ABC is on PQ. So the mass of the triangle ABC is capital M, that is 27 xy. So we can write this way, 27 xy, 27 xy rho into 0, because center of mass, we are going to measure all the center of masses from PQ. The question says from PQ. So center of mass of this initial triangle is on PQ. So the distance is 0. From that, this triangle is removed. Its mass is 12 xy rho. So 12 xy rho. Its center of mass is at a distance of 1/3 of h. H is 6y. 1/3 of h. It's on other side. I'm going to take downward direction positive. Below PQ is positive. So it's going to be other side, means minus, because it's on the other side. 1/3 of 6h. 1/3 of 6y. Sorry, 6y. Right. Now it's removed. Now after removing it, we are going to add it like upside down. Now the same triangle added, so plus, its mass is the same, 12 xy rho. Now the center of mass of this triangle, the same triangle added upside down, from PQ, from the base is 1/3 of same thing. But on the downward direction, we take downward direction positive. So into 1/3 of 6y is equal to, now this is the final thing. From the big triangle, we removed this smaller triangle, so we subtracted this minus sign because this is on upper direction. Downward direction, below that we are taking positive. If the particles are on either side, this is M1, this is M2, this is M3, means one direction we have to take. This is X1, this is X2, this is X3. So we have to take one of the direction positive. If I take this X1, X2 positive, means X3 should be taken negative when we are writing sigma in my xi. Okay, so this is removed. So that's the reason minus sign. This minus sign indicates removed. This minus sign indicates on other side. The center of mass of A, PQ is on upper side. This plus sign indicates we are adding the triangle again. We are attaching, adding that mass triangle. This plus. This center of mass is written positive because from here we are taking downward direction positive. Okay. Now from the triangle we removed it. We got trapezium. Then we added the triangle again, APQ upside down. We will get this shape, is it? Now what's the total mass of this shape? Same as the same material. It's the same thing, only folded. So the mass is same as 27 xy. 27 xy rho. Its center of mass from PQ, it's going to be anyway downward, nothing upward, downward, so it's positive into D. We need to find the D. Solve it, you'll get the D. So all the xy row will get cancelled. So here 27 minus xy row got cancelled. So here minus into minus plus, 3 into 12, 4, 1/3 into 12, 4, is it? 4 into 6, or you can say this is 2 here, 3, 6y here 2. We'll divide whole equation by xy row, so that's going to be 2 plus 24 y, yeah, 24y, here sorry, here xy is 0, sorry, this is going to be 0 plus 27 xy row into 0, so that is 0. So this is minus into minus plus, this is 2, 24 xy row, we can get cancelled, xy row everywhere, so that's going to be 24 y plus here 2 again 24 y is equal to 27 D. So that's going to be 27, D is going to be 48Y. So D will be 48 D over 27. So if you divide by 3 up numerator and denominator, it's going to be 16 over 9Y. That's the answer, no? He has to show. Yeah, 16Y over 9. You got it. So remember that adding a particle is newly added plus with the initial center of mass. If a particle is removed, minus something. And also we have to consider the direction. This is first method. Second method, we can find the center of mass of the trapezium after when we remove the triangle APQ, we can find the center of mass of the remaining trapezium. Then we'll think about the center of mass of the triangle after it's added. That way also we can do. I'll do that method also. This is first method, adding, removing method. Just one line I wrote it. Okay, this is one step more. So mass of the APQ, we found it already. Now what's the mass of the trapezium? Mass of the trapezium PQ BC, that is M2 is equal to total mass that is 27xy rho minus 12xy rho, 27xy rho minus 12xy rho, that is 15xy rho is the mass of the trapezium. Okay, one step more, but nothing wrong. Now we are going to find the mass of the trapezium, center of mass of the trapezium from PQ. So here we are not considering this part is upside down. After it's folded like this, we are going to find the mass of, center of mass of the trapezium from PQ. How to find it? Now it's like this. Now the center of mass of the trapezium, okay, we know here this side. Here we know the this triangle is the big triangle ABC is made of the trapezium PQBC, and the triangle AQP. So we know the center of mass of this big triangle is 1/3 from the BC, means it's on the line PQ. Center of mass of AQP will be upside above this one. Center of mass of the trapezium will be below. One side we had to take positive. So we assume this triangle is due to addition of this triangle and the center of this triangle and the trapezium. So when we take that idea, the center of mass of the triangle ABC is at PQ, means the total mass, that is 27xy rho into 0. We are finding the center of mass of the trapezium and the triangle AQP and the big triangle ABC, everything from PQ. So for the big triangle ABC, the center of mass is on the PQ, so 0 is equal to sigma mi xi. Okay, so we are going to write now. So that's going to be total mass into center of mass, which is at PQ. So the distance of the center of mass of ABC is on PQ, so distance 0. We'll take one side positive, we'll say downward positive, means the mass of the trapezium, that is 15xy rho into, we are going to find its distance of center of mass from PQ, let it be y1. We are going to find the y1 bar, we are going to find it. For the triangle, this one, its mass is 12 plus 12xy rho into minus, because its center of mass is upward, opposite to downward, upwards 1/3 from PQ, 1/3 of symbol h is 6y, 1/3 of 6y is 2y minus 2y. Okay, so y1 bar, we'll find it. y1 bar is the distance of the center of mass of the trapezium PQBC from PQ. So solve it and you will get y1 bar is equal to 8y over 5. So center of mass of the trapezium PQBC from PQ is at 8y over 5. Now we have to find the center of mass of this lamina, is it? Now we can assume this lamina is made of this trapezium and the upside down triangle PQA. the upside down triangle PQA, that forms the new lamina. So for that, we know the total mass of this lamina is 27 xy rho, so that we can say 27 xy rho into d. D is the question, they are using the d for the question, is equal to this center of mass of the mass of the trapezium, that is 50 xy rho, into its center of mass from PQ, everything I measured from PQ, that we found it 8y over 5 plus mass of the triangle PQA, that is 12xy rho, its center of mass from PQ, 1/3 of this height. Anyway, this height is same as this height, it's folded, it is h, that is 1/3 of 6y, that is 2y. Okay, now solve it and find the d in this one. Everything we know, find the d. You'll get the same answer as earlier. That will be 16 over 9 y. 16 over 9. 16 over 9 y. Same answer as earlier, you will get it. Either way you can say. Here one step more, we are finding the center of mass of the trapezium. Then we are substituting that to find the center of mass of the lamina after it's folded. Earlier we are subtracting and adding. All same, but steps are different. Number of steps. Okay, we know that this center of mass, we found it from the distance from PQ. So here also, like October 2022 paper, here also we don't know the exact point. We are finding the distance of the center of mass from a line. But we know due to symmetry, the center of mass will be along the line that connects the center of the BC to the vertex. So the center of mass will be along this line here. We don't need to find the center of mass from another axis, because due to symmetrical shape, the center of mass is along this line from here, 16 over 9 y. But you can see the October 2022 paper, the shape was like this, the shape what is given, something like this, is it? So it's not symmetry. When we found the center of mass from this line, something we got it, but that is not symmetry. That we only know the distance of the center of mass from this line. I think we found it from this line, but to find the exact point, we need to find again from this line. But here we don't need, because due to the symmetrical shape, the center of mass we found it from PQ, but we know that about the center line, the bisector of the line PQ which connects to the vertex A, on left side and right side they are symmetrical. So we know that center of mass is on this line at a distance 16 over 9 y. We don't need to find the center of mass from another line again for the next part, the B part. We don't need to find it. When it is hung to find the angle, we don't need to find it here. But for October 2022 paper, we have to do it because it's not symmetry about this axis and this axis, it's not symmetry. Okay, question number 3, B part. The folded lamina is suspended from P and hangs freely in equilibrium with PQ at an angle alpha to the downward vertical. Given that tan alpha equals 64 over 81, find x in terms of y. Okay, that's the question. Find x in terms of y. Okay, so we know we found the length PQ, that is 4x. We found it in the first part. This is 4x. BC is 6x. We know that. Okay, now it's hung by using PQ. So again, this question appears in all papers. So that means if you have a lamina, it's a uniform or non-uniform shape. If you hang it from point P and the center of mass is here, what will happen? The weight will act at the center of mass G. So when you hang it from point P, due to the weight, there will be a clockwise moment about P. So it will rotate until the point G comes exactly below P, something like this. This is the P. Until the G comes below that, it will rotate. Then when G is exactly vertically P, it will be at rest due to the clockwise moment. But if you hang it like this in deep space where there is no gravity, it will remain the same. But due to the weight provided by the gravity, it will have a clockwise moment about P. Same way, so here they are saying the folded lambda is suspended from P, so it's suspended from B. So center of mass, we found it from the line PQ. I already explained, due to the symmetrical shape, it will be on the axis which connects the vertex A and the bisector of PQ. So on this line at a distance from PQ at a distance of 16 over 9y, this is the center of mass G. This height will be 16 over 9y. At that distance, the center of mass exists. So this line is 16 over 9y. So this point from P, if I name that point N, Pn will be 2x, because symmetrical nature, due to the symmetrical shape, that will be the bisector 2x. Okay, so they are saying when we connect, the line PQ makes an alpha with vertical. So vertical means the line PG will become vertical. I explained. So it will rotate until the center of mass becomes exactly below the point from where it is hung. So here G will, the shape will rotate until the point G comes exactly below P. So the line PQ also will be shifted through the same, and when this G comes below and rotates, PQ also will turn. They are saying the line PQ is making an angle alpha with the vertical, means here the vertical line is PQ. So the line PQ is the vertical. Okay, this is the alpha. Now the PQ will be vertical. I don't need to draw, very difficult to draw rotating the shape such that PG becomes vertical. But anyway, PG is going to be the vertical because G will become exactly below P. Okay, I need to find the alpha. So this tan alpha, B part, tan alpha is going to opposite NG. I named the center point N, NG over PN. So NG is 16 over 9y, 16 over 9y is NG. Pn, what is Pn? 2x. But tan alpha is given as 64 over 81. It says tan alpha 64 over 81. So from this we can solve this. That is 64 over 81 is equal to 9 goes down 16y over 18. Okay, we'll see. Uh, 18x, sorry, 18x, yes. So how much is x? X is going to be I think, so x is going to be, take the x subject, so 16 into 81y, approximately 16 into 81y over 64 into 18, 16 into 81y over 64 into 18, so it's going to be 9 over 8y. So from this, x is equal to 9 over 8y. That's the relationship between x and y. Okay, question number 4 is on momentum. A particle P of mass 3m and particle Q 5m are moving in towards each other along the same straight line on a smooth horizontal surface. The particles collide directly. Immediately before collision, the speed of P is u and Q is ku. After collision, P 2v and the Q is v. So P has greater speed, Q less. The direction of motion of each particle is reversed by collision. Okay, so if I put it on a diagram for this, particle P of mass 3m moving at a speed u, particle Q of mass 5m moving at ku. This is before collision. After collision they are reversed. So the P which has mass 3m becomes 2v, and the Q which has mass 5m becomes v. Okay, so the direction of motion each particle is reverse. In the collision, P receives an impulse of magnitude 15 MV. So both will have the same magnitude of impulse according to Newton's third law, but they are saying P receives an impulse of 15. So I is equal to 15 MV. That is same for both. Question, show that U is equal to 3V. Okay, so we can show that. So there's K is there for the particle, Q has Ku. So we'll do for P. So first part, we want to get the value of, we want to get a relationship between U and V. So if I try to use particle Q and the impulse, I'll have trouble because K will appear in my equation. To avoid it, we'll do it for the particle P. So during collision, according to my diagram, during collision, the P will experience force this way, Q will experience, this is P, this is Q, Q will experience force this way when they collide, P and Q. So the impulse on P will be towards left according to my diagram. So I'll use I equal mv minus mu for P. I know that is towards left. Okay, so that is 15 mv I'm using for P. Final velocity to the left. So 3m into 2v minus, I need to use for left because I know the P is going to experience impulse to the left. So mass of the P is 3m into final velocity 2v minus, this minus appears, the mass is again 3m, U is towards right, 2 is right means minus U. So it's going to be 15 mv is equal to 6 mv plus 3 mv, all the m will get cancelled, you will get 3u is equal to 9v, so u is equal to 3v. Okay, second part, B part, find the value of k. Now use it for, I know the relationship between u and v. Now use the same equation, I equal mv minus mu for the q, or you can use the law of conservation of momentum, either one, you'll get the same answer. But I'll use, this is A part. Now B part, I is equal to mv minus mu towards right for q. Same impulse, 15 mv, mass of that is 5m, final velocity is towards right, minus initial velocity of this one, q is towards left, so 5m minus ku. Okay, so it's going to be 5mv, all the m will get cancelled, so all the mv get cancelled and the 5 I can divide, so 3v is equal to v plus 5m ku. Okay, instead of k, instead of v, substitute the answer should be on same units. Yeah. So here u, here v, here v. So instead of u, substitute 3v here. So that means if I continue here, 3v is equal to 3v minus v, 2v. Yeah. So 2v is equal to k into, instead of u, put 3v. So k is going to be 2 by 3. Okay, part C, it says that the coefficient of restitution between P and Q is E. Find the value of E. So coefficient of restitution is something related to Newton's law of impact. It says relative speed of separation is equal to E times relative speed of approach. So here the relative speed of separation, they are separating in opposite direction. So relative speed of separation, that means the relative speed means 1 second, during 1 second this will move towards right a distance v, this will move towards left 2v, so the distance gap between the two will increase by 3v during 1 second. So the relative speed is 3v, so that is 2v plus v is the relative speed of separation, that is equal to e times relative speed of approach. Here also they are approaching, means moving in opposite direction, so u plus ku, okay, nothing, you can substitute the value of u, sorry, the u in terms of v, and value of k, when you substitute you will get the answer. So it's going to be 3v is equal to u into k1 plus 1 or k plus 1. Okay, so instead of u you can substitute 3v, so that is 3v equal e times 3v into k, you can substitute 2 by 3 plus 1, so that is 1 is equal to e times 5 by 3, so e is going to be 3 by 5, that's answer. Yeah, 3 by 5, yes. Okay, part D, the total kinetic energy lost in the collision is lambda mv squared. Find the value of lambda. Lost means initial minus final, is it? So initial kinetic energy minus final kinetic energy is equal to lambda mv squared. So that is initial kinetic energy minus final total kinetic energy. Actually, initial total kinetic energy minus final total. We have to consider both particles equal lambda mv squared. Okay, so initial total kinetic energy half times 3m u squared plus half ku, we had substituted the value of k, ku in half into mass 5m into ku all things squared, ku all things squared, minus final kinetic energy. Whether they are opposite or same, we don't concern negative, positive. Kinetic energy is a scalar quantity. Just find the numerical value. Don't consider direction because it's a scalar quantity. Half 3m into 2b squared plus half 5m v squared equal lambda mv squared. Okay, so we can substitute everywhere. Instead of u, we can substitute 3v. Yeah, instead of k, substitute what we found 2 by 3 and solve it. You'll get the value of lambda. All the m now going to get cancelled everywhere. The m will get cancelled. So we'll substitute half m. We don't need to write 3. Instead of u, you can say u is equal to 3v. We will keep everything in the same. U equal 3v, we will put it. So it's going to be 3v, all this squared means 9v squared, is it? So m will get cancelled, half into 5. K is equal to 2 by 3. So 2 by 3, k is equal to 2 by 3 times u, 3v. 2 by 3 is k. U is 3v, so this 3 and all things squared we need to find it. 3 get cancelled. 2v means 4v squared. That will be 4v squared minus half times 3 times 4v squared plus half times 5 times v squared equal lambda m v squared. Check it carefully. Lot of things are there. Chance to make careless mistakes. Okay, solve it. So here all the v squared will get cancelled. So half into, okay, so when you solve you will get m, this m is gone, this m is not necessary, into v squared. Okay, so all the v squared now can be solved or can be cancelled. So remaining 27 by 2 here. Anyway, solve it, you get the answer. All the v squared could be cancelled. So finally you will get lambda is equal to 27 over 2 plus 10. This is 10, I think, yeah, 4, 10 minus, this is 27 over 2 lambda. So v squared, v squared, v squared, v squared get cancelled. I wrote the lambda subject. So 27 over 2, here 20 by 2, 10 minus here, this is this is 6 plus 5 by 2, that is going to be 17 by 2. Solve it. So 17 by 2. So 17, 27 minus 17, that's going to be 10 by 2, 10 by 2, 5. So 15. That's the final answer. Yes, lambda 5 is the final answer, correct answer. Okay. Nothing, just working a lot. That's all, nothing, no big logic. So question number 5, a uniform rod AB of mass 15 kilogram and length 6 meter rests with end A on rough horizontal ground, then B of the beam rests against a rough vertical wall. The beam is inclined at 75 degrees. Portion of friction between beam and the wall 0.2. So here between the wall, here mu is equal to 0.2. Mu1 we can call mu1 equal to 0.2. The coefficient of friction between beam and the ground is mu. So here it's mu, which is unknown. The beam is modeled as a uniform rod which lies in the vertical plane. Beam rests in limiting equilibrium. So both points at A and B, ground and the wall, the friction will be there. It's going to be F equal mu R. Mu means coefficient of friction, but we have to choose the proper mu. F equal mu R because it's at limiting equilibrium. Find the magnitude of the normal reaction between the beam and the wall at B. Okay, we'll think about the forces acting on the rod AB. So if I draw the rod again and showing only the forces acting on it. So it's a uniform rod AB 6 meters. So the weight will be at the center at 3 meters. This will be its weight. Mass 15 kilogram. Anyway, I'll put mg, mass into g. So this is the point A. So it's at limiting equilibrium. It will try to slip to the left. So the friction will be to the right. F equal mu R. So this is a friction. Mu times R1. This is mg. Mu times R1. R1 is the normal reaction here at A. And at B there will be normal reaction from the wall, that is perpendicular to the wall. Let it be R2. It will try to slip down. The friction will be vertically up. That is if R equal, the friction again is equal to mu R. Mu is 0.2. We know that. So I'll write it as mu1 R2. R2 is the normal reaction at B. This is the center of mass, capital G. So AG is 3 meter, GB is 3 meter. The question is, find the normal reaction. That is, they ask you to find the R2. Okay, so if I try to take moment about A, it will be a problem because this also will include. But anyway, we can take moment about that point, no problem. Yes, we'll take moment about A. That's the only method. We'll take moment about A. So then these two forces, the friction at A and the R1 will not come. We need to find the R2. We know the weight. Okay, so take moment about A. So first A part. About A. So it says force into perpendicular distance to the line of action of force. Line of action of force for the weight is this one. From A, this is the line. So this the weight is acting this way, point A. So this is the line of action. This is the line of action. This is the perpendicular distance. That is going to be AG. This angle 75 degree. AG cos 75 is this perpendicular distance. So that will be clockwise moment. So we will take moment about clockwise. It's going to be mg, that is 15 mass is 15 into 9.8 into AG, this length is 3 cos 75. Then when we consider moment for R2, that's going to provide anti-clockwise direction. So minus R2 into the perpendicular distance to line of action of R. Line of action of R2 is this one. From here, this line, this vertical distance, that is this total length AB sine 75. So this length is sine 75. So AB is 6 sine 75. Same way, this friction also going to provide anti-clockwise moment about A. So minus friction is mu1 R2. Mu1 is 0.2. So 0.2 R2. The line of action of friction is this one. Perpendicular distance from here is this length. This length. The force is acting this way. The line of action. Perpendicular distance from here to here. This one. That is 6 cos 75. Okay, we know everything. R2, R2. That's the only unknown. So we can group this R2 outside. Anyway, that's simple maths algebra. Solve it. You will get R2. So it's equal to 0 because it's at equilibrium. Okay, find the R2. Solve it. So we'll get R2 is equal to, solve it, 18.7 Newton. You can take it to the right side, R2 common within bracket 675 plus 0.2 into 6. It's algebra, that's not an issue, but final answer is this one. Okay, second part. Find the value of mu. Okay, find the value of mu. We will find the value of mu means they ask you to find the mu value. So mu, since it's at equilibrium, the total force, these are the total forces acting. The weight mg at the center. Here there's a friction, there's a normal reaction, there's a normal reaction from the wall friction. So there are 1, 2, 3, 4, 5 forces acting on the rod AB. So it's at equilibrium means when we resolve all these 5 forces to any direction, we should get 0. So if we resolve it horizontally, we should get 0. So B part, you resolve all the forces into horizontal direction. That is FR, that is mu R1. Horizontally, this is vertical, no component. So that means horizontally we consider mu R1. Okay, so if I say mu R1, minus R2 equals 0, but R1 is unknown. So first we will find vertically, right? Vertically we will find the R1. So vertically we will find it. R1, this is downwards, minus mg, this is upwards, plus 0.2 R2, that is this friction, 0.2 R2 equal to 0. So we will find the R1. R1 is equal to, when you take it to the right, Rg minus 0.2 R2, that is 15 into 9.8 minus 0.2 into R2, 18.7. So you will get R1, 143.3 Newton, 143.3 Newton. That is R1. Now, as I told earlier, we'll resolve all the forces into horizontal direction. So we don't need. So we'll resolve all the forces into horizontal direction and it must be equal to 0. So mu R1, this is the horizontal force, this is vertical, this is opposite, minus R2 equals 0. So mu is equal to R2 over R1. So that is going to be R2, we found it 18.7 over R1, 143.3. So that will be 0.13. That's the final answer. Okay, question number 6. A van of mass 900 kg is moving along a straight horizontal road. The resistance to the motion of the van is modeled as a constant force of magnitude 600 Newton. The engine of the van is working at a constant rate, 24 kilowatts. Every year this question comes, the same pattern. At the instant when the speed is v, the acceleration is 2 meter per second squared. Find the value of v. So we need to find the actual forces acting on the van, that is the forward thrust due to the engine, and there will be drag. So we know that forward thrust we can find by using P equal FTV. So P we know that 24,000 is equal to Ft, the speed which is we need to find it. Okay, so Ft is going to be 24,000 over V. So F equal ma we are going to write along the direction of acceleration. So there will be two forces, one is the forward thrust and the other one is the friction. So Ft minus friction Fr is equal to ma. So Ft we can write 24,000 over V minus friction is given 600 equal the mass is 900 times the acceleration is 2. From this find the V, that is equal to 10 meter per second. That's the answer for first one. Nothing, just substitution. Okay. Okay, so the second, same question, B part. Later, the van is towing a trailer of mass 700 kilogram up a straight road inclined at an angle theta, where sin theta 1/14. Trailer is attached to a van by a tow bar as shown in figure 3. The tow bar parallel to the direction of motion of the van and the trailer. The resistance to the motion of the van from the non-gravitational force is modeled as a constant force of 600 newtons. So students normally ask, why do they use the word resistance to the motion of the van from non-gravitational force? Actually, when something object moves upward direction, the gravitational force which opposes the motion is the component of the weight, mg sin theta. Mg sin theta is the component of the weight parallel to the slope that also will oppose the motion. This is non-gravitational force, is friction. So there is a friction acting on the trailer, acting on the van, which is 600 newton. So that is 600 newton acting here. Also there will be component of weight is there, mg sin theta, that also opposing the motion of the van. Then the resistance to the motion of the trailer 550. So for the trailer 550, it also has its component of weight m1g sin theta. Both will have their component of weight which oppose the motion. The tow bar is modeled as a light rod, so the tow bar has no mass. So the tension will be the same, and tension is negligible. Mass means 0 means there is no tension we have to take. So why, you might ask, F equal the tension, if I consider tension, if I consider T, so sorry, the tension, the mass becomes 0, so the acceleration 0. So the tension will be, there will be tension, but tension will be the same at all points. That's a reason we should take. Okay, so acceleration is there, but mass is 0. The engine of the van is working at a rate of 24 kilowatts. So there will be a forward thrust on the van Ft. Find the acceleration of the van at the instant when the van and the trailer are moving with speed 8 meter per second. Okay, nothing, we need to use F equal ma. So the forward thrust is there for the van. When we consider for the whole system, that's the way we normally do. Then we can avoid finding the tension on the rod. So for the whole system, when we consider, first we will find the Ft. So power equal force into speed. So power we know 24 kilowatts. So 24,000 is equal to forward thrust into speed is speed given as 8 meter per second. So Ft we can find it 24,000 over 8, that is 3,000 Newton. That's a forward thrust on the van. So we'll use along the slope upward direction F equal ma for the whole system. So we don't need to consider the tension on the rod. So that is Ft minus this friction 600 minus m1g sine theta, that is for the van. Then for the trailer, minus m2g sine theta minus 550 equal to ma, the total mass, m1 plus m2. The question is find the acceleration. Okay, so Ft is 3000 minus 600 minus m1 is 900 into 9.8. Sin theta is given 1 over 14 minus m2 is 700 into 9.8 into 1 over 14 minus 550 is equal to, we have to add both masses, that is 900 plus 700. That's all, everything we know except A. Solve it, we'll get the A. So A is equal to 0.46 meter per second squared. Yeah, the answer correct, 0.46 meter per second. Careful, there are a lot of numbers, but answer correct, yeah. Okay, question number 6, C part. At the instant when the van and the trailer are moving up the road at 9 meter per second, the tow bar brakes. The trailer continues to move because when the van moves at 9 meter per second, the the trailer also moving at 9 meter per second. When the tow bar brakes, it won't come to stop immediately because it has speed 9 meter per second. So it will continue to move until the speed becomes 0. It will decelerate. Why does it decelerate? Because of the opposing forces. What are the opposing forces on it after the tow bar brakes? One is the component of its weight, that is mg sine theta. Then the friction. It says friction is 550 Newton. Yes, friction 550. So these are the two opposing forces. So due to these opposing forces, the trailer will decelerate from 9 meter per second to 0 and it moves the distance d along the slope. The angle same theta. The height it moved is h sine theta. The question is by using work energy principle to find the value of d. Okay, so when it moves, we can write loss in kinetic energy equal to gain in GP plus work done against friction. I'll write here. We'll write here loss in kinetic energy equal gain in GP plus work against friction. We can use Newton's second law here. We can use the Newton's second law, deceleration, find the deceleration, and then we can find the d. But it's restricted. We can't do that way because they ask you to do work energy principle. Means we have to write this equation, loss in kinetic energy, because the kinetic energy here due to 9 meter per second, there is no kinetic energy. It's losing the kinetic energy. It's moving up. Because of losing the kinetic energy, it's moving up. So there is gain in GP. There are frictions opposing the motion, so it's able to do work against friction because of losing the kinetic energy. So loss in kinetic energy equal gain in GP plus work done against friction. You should be able to identify the energy transfer that happens. But we can do by using Newton's second law. We can find the deceleration first, then we can use the equations of motion, v squared equal u squared plus 2s along the slope up. Yes, you will get the same answer, but here we can't do. The question is restricted to do by using work energy principle. Okay, we'll continue this way. Loss in kinetic energy, initial kinetic energy, half mu squared minus half mv squared, but anyway v is 0. Gain in GP, mg h plus work done against friction, the opposing force into distance moved. H we can put, H is equal to d sine theta. This is d sine theta. H is equal to d sine theta. Okay, so half the mass of the trailer is 700 into 9 squared. Initially it has speed 9. Finally the kinetic energy becomes 0, equal to 700 into 9.8 into H is d sine theta. We need to find the d sine theta. Sine theta we know 1/14 plus friction. Friction is 550, not mg sine theta. The mg sine theta we should not take it as a work done against friction, because of mg sine theta we have gain in GP. Careful students make mistake that when you are finding the work done against friction means we should not include the component of the weight. Component of the weight is included in the form of gain in GP, right? So careful. So 700 into 9.8 d sine theta plus work done against friction 550 the friction. We have to include the non-gravitational forces when we talk about work done against friction. 550 into d. That's all. So again, this we can say half into 700 into 81 equal to 700 into 9.8 d sine theta 1/14. Yes, 1/14 plus 550 into d. We need to find the d here. Solve it and find the d. So carefully solve here. There is d, here there is d. Take the d out. You will get 27.3 meters. Okay, I can write step by step. This one is 28350 equal to 490d plus 550d. Okay, now solve for d. D is equal to 27.3 meters. Okay, question number 7. This diagram is given. It's on projectile motion. A small ball is projected with the velocity 3i plus 2j. That means the initial velocity, horizontal component 3 meter per second, vertical component 2 meter per second. The point A is 20 meters above the horizontal ground. The ball hits the ground at point B as shown in figure. The ball model as a particle. By conserving energy, find the speed of the ball at the instant immediately before it hits the ground. Okay, so we know the initial kinetic energy, we can find it. So A part, initial velocity u square is equal to 3 squared plus 2 squared, that is square root, that is 9 plus 4, 13 meters squared. S minus 2 is the initial speed. Okay, so we can write for the motion from A to B, loss in G, it's moving down, loss in GP equal gain in KE. For the motion A to B, we can consider loss in gravitational potential energy equal gain in kinetic energy. Loss in GP m GH equal half m v squared minus half m u squared. All the m will get cancelled. 9.8 into h is 20. It's moving down by 20 meters. Half into v squared is the question, minus half into u squared is 13. So from this, find the v. They will get 20.1 meter per second. Okay, that's the answer for first part. So just before hit the ground, its speed is 20.1 meter per second. B part, find the direction of motion of the ball at the instant immediately before it hits the ground. So we know that projectile motion, we don't consider the drag force. So horizontally, no acceleration, no drag means the 3i component will remain unchanged. So 3i component will remain unchanged means we can find only the vertical component of the velocity just before it hits the ground is it. So they ask you to find the velocity, they ask you to find the angle. So we'll find the vertical component of the velocity just before it hits the ground. Horizontal component remains 3. So downwards we'll use v squared equal u squared plus 2as. V squared we are going to find vertical component downwards. Initial velocity vertically is upwards 3 but minus 3 all things squared, sorry, minus 2, the vertical component is 2, minus 2 all things squared plus 2 into 9.8 into this displacement 20. So find the vertical component just before it hits the ground. It's going to be 19.99 meter per second. So just before it hits the ground, the vertical component is 19.9. Horizontal component remains same, which is 3. So the resultant velocity is somewhere here. This theta, tan theta, that's the question. They have to find the angle ball in, before it hits the ground. We can find it with the horizontal line. They are not telling which angle. Tan theta is equal to 19.9 over 3. So find the theta with horizontal. It's going to be 81.4 degree with horizontal. Okay. Okay, C part. Find the time taken to reach the ground. So we know the speed just before hit the ground vertically. So use vertically. V equal u plus 80 vertically. So vertical component is 19.9 equal initial vertical velocity upwards, which is 2j. So minus 2, we are using downwards, plus 9.8t. Find the t. So you will get 2.23 seconds. Okay, so next part. At the instant when the direction of motion of the ball is perpendicular to 3i plus 2j. Okay, careful. Perpendicular to 3i plus 2j. So 3i plus 2j is the initial velocity. The velocity becomes perpendicular to this one. During the motion, somewhere the velocity, you know, when a particle moves in during projectile motion, it will be along the tangent to the trajectory. So somewhere when you draw a tangent, it should become perpendicular to the initial direction. When it becomes perpendicular, it is at a height h meters above the ground. Find the value of h. Okay, so find the value of h. Perpendicular. So here the only option we had to use, it's easy to use dot product of vectors. So you know when you consider vectors, there are two different types of products. One is called dot product, other is called cross product, or another name. Dot product is called scalar product, cross product is called vector product. Anyway, here we don't need vector product, we need to do scalar product. So when there are two vectors A and B, say this is vector A, this is vector B, the angle between them is theta, the A dot B is defined as, the dot product of two vectors is defined as mod A times mod B into cos theta. Theta is the angle between the two vectors. If the two vectors are parallel to each other, A and B are parallel vectors, then mod A dot B is equal to mod A mod B cos theta. Theta is 0, so it will be 1. If the two vectors are perpendicular to each other, then A dot B will be equal to mod A mod B cos 90. Cos 90 equals 0 because 90 degree. So 0. So the dot product will become 0. Very useful in certain applications. When you consider unit vectors I, j, k, the vector I and vector j are perpendicular among them. So vector I dot vector j is always 0. If it is 3-dimensional ijk format, I into j 0, j into k 0, k into I 0 because they are 90 degree among them. For example, how to find the dot product of vectors in terms of unit vector. Say for example, a vector is equal to xi plus yj. Then vector r is equal to, this x1i, xy1j. Vector r, say a1, vector a2 is equal to x2i plus y2j. How to find the a dot b, a1 dot a2, vector a1 dot vector a2, how to find it? That is x1i plus y1j dot x2i plus y2j. Okay, just normal algebra multiply x1i into x2i. So that means x1, x2 are scalars. I dot I, that is I dot I. How much I dot I? I dot I mod I times mod I cos 0 mod I. I is a unit vector, so it's going to be unit vector 1 times 1 cos 0 1, so it's going to be 1. So x1i dot x2i, x1 into x2, x1 x2, I dot I 1. Okay, leave it. Now x1i plus x1i into y2j, I dot j 0, I dot j 0 because they are 90 degree among them. So I dot j 0. So x1i dot y2j won't be there. Same way y1j into x2i won't be there because I and j perpendicular among them. y1j into y2j, that is y1 into y2, j dot j, again unit vectors j, it's going to be 1. So x1, x2, y1, y2. Okay, so we are going to use these techniques here. So they are saying the velocity becomes perpendicular to the initial velocity. So we know that during the motion, wherever the particle, the horizontal component will remain same. The horizontal component will remain the same. It won't change. We know that because we don't consider drag force and we know horizontally there is no acceleration. So the velocity when it becomes perpendicular to this one, so we'll see the initial velocity is 3i plus 2j given that meter per second. When it becomes velocity perpendicular, we'll take it as the I component, the horizontal component remain the same, can't change because I told them at any point the horizontal component of the velocity is the same, no acceleration in horizontal direction. So that is going to be 3i. But vertical component, we don't know the vertical component of velocity, so we'll take the vertical component as yj. Vertical component of the velocity, we'll take it as yj, we don't know what is it. But they are perpendicular, initial velocity and this velocity, they are saying perpendicular, they become perpendicular means u dot v should be equal to 0 because mod u, mod v, cos 90 because they are perpendicular, cos 90 0. We'll substitute 3i plus 2j into 3i plus yj, the vertical component, yj, the velocity, equal to 0. Solve it. 3i, 9. 3 into 3, 9. I dot I, 1, 9. 3i, yj won't come because I into j 0. 2j, 3i won't come. 2j into this one plus 2y equal to 0. Is it? I'm right, no? 2j into 3y, 2y, j dot j 1. So 2y equal to 0. So that means y is equal to minus 9 by 2. So the velocity which becomes perpendicular is equal to 3i minus 9 by 2 j. This is the velocity which is perpendicular to the initial velocity. Okay, right. Now what is the actual value of this velocity? We'll find the magnitude of it. This is the components, horizontally 3i direction, vertically 9 by 2j minus. So this I can say plus 9 by 2 into minus j, minus sign by the downward direction. J is upward direction, this is downward direction. So the magnitude of the velocity when it becomes perpendicular, square root of 3 squared plus 9 by 2 squared meter per second. Find it, the velocity when it becomes perpendicular, you will get okay, we can use the actual velocity, but wait, we can find the actual velocity, but we don't need, because I am going to use, they are asking to find the height. Okay, so anyway, you can find the magnitude of the velocity, but they are saying it is at a height h above the ground, h above the ground. We need to find the h. We will find when the vertical component, horizontal component remain the same, horizontal component remain the same, and the vertical component becomes 9/2 downwards, minus sign is there, downwards, because j is upwards, so I can write this 3i plus 9/2 minus j. Anyway, it's not a big issue. Minus j means downward direction. When the velocity, vertical component becomes 9/2, what is the displacement? I can find the displacement vertically down. So somewhere here, when it comes to this position, its velocity, vertical component is 9/2. Okay, so for that, to find the vertical component becomes 9/2, what is its downwards displacement? I want to find this downward displacement, so I can use downwards. V squared equal u squared plus 2as downwards. V squared, the vertical component of the velocity is 9/2, that means 9/2 squared. Initial vertical component, that is 2j, that is 2 squared plus 2 into 9.8 into the distance it has fallen down, I can call it as capital H. So find the h here, capital H, the displacement vertically down, how much it moved down when the vertical component of the velocity becomes 9/2 meter per second downwards, that becomes 0.83 meters. But the question is, find its height from the ground. So we know this is 20, this is 0.83, so h is equal to 20 minus 0.83, so that will be 19.2, I think 19.2 meters. That's the final answer. Okay, so that's the final answer. Okay, so yeah, I hope you understood this paper also. We'll meet when we discuss another paper. You can pass your comments. Yeah, bye.